Hello there, and then welcome to a brand new video. This is Half Beyond Numbers, where we learn maths the easy way. I do hope you are doing well, and then your learning journey is also going well by God's grace. Now, by the end of this lesson, we would have looked at enlargement and then what it means in geometry. And then we'll be able to identify the center of enlargement and then the scale factor. Then you should be able to enlarge 2D shapes using a scale factor. And then after it all, you should be able to identify when we say an object has been enlarged, a reduction being or a reduction, and then the same side. So without much ado, let's quickly look into it. Okay, so let's look at this note we have here to explain what enlargement is all about. So first of all, enlargement is a transformation that changes the size. So take note that it changes the size of a shape but keeps its what shape and angle size the same. So after an enlargement, you should realize that the shape of the original figure and your enlarged figure would actually be the same. Not talking about size. And secondly, the angle size will also remain the same. What does that mean? Let's take this figure here, for instance. Let me make it small. Okay. So let's take this figure here, for instance. Okay. Now, if I'm to enlarge it, you see this angle over here. These angles are all 90 degrees, you see. And you know this is a rectangle. If I'm to enlarge it, the new shape over here is also a rectangle. Do you see that? The angle has been preserved. The 90-degree angle, they've all been preserved. And it's still the same shape. It's just the size that has been changed. You get it? Okay, so that is what the first line is telling us over there. Then you have to take note of the following in enlargement. That is, it can make a shape larger, smaller, or even stay the same, depending on your scale factor. So once again, if depending on my scale factor, after an enlargement, I might get a shape like this, which is smaller. You see, depending on the scale factor, I might even get a shape like this, which is, let me say, the same as the previous one. And depending on my scale factor also, I might get a shape like this, which becomes bigger. You see, now take note that the second point says every point on the shape, there's a shape over here, okay? So every point on the shape moves away from or towards a fixed point called the center of enlargement. So with this over here, if I put this point over here like this, and I now choose to enlarge this way, you see that all the points are moving away from this point, you see. And if I choose to, let me say, enlarge with another scale factor, which is smaller, all the points will then be moving towards what we have over here. So if I enlarge it further, this is what is going to be over here. You see that? Okay. So that is just an introduction on, on enlargement. Now that we know what enlargement is, there is a need for us to know what we call the scale factor. The scale factor. So let's quickly look at what the scale factor also is on the other hand. So this here is a little note on the scale factor. The scale factor tells us how bigger or smaller the image will be compared to what the object. And as you know what the image is and what the object is. The image is whatever you get after the enlargement. The object is the original figure. Okay. So if the scale factor, which we are using the variable k to represent, if it is greater than 1, then we say the image enlarges. The image has undergone enlargement. I would make an illustration of all of this, but for now, let me explain. Then afterwards, we look at the illustrations. So as I've said earlier on, if the k, which is your scale factor, is greater than 1, the image enlarges. All right, it enlarges. Then if your scale factor is between 0 and 1, the image is going to shrink or it's going to reduce in size. And we call that reduction. Now, if your scale factor is 1, then the size of the image and that of the object are all the same. But if your scale factor is less than 0, then your image will just flip. So this here is an illustration of all that we have said so far. This is when your scale factor is greater than 1. So the yellow one would be my object. Okay. So for all these illustrations, the gold, the one in yellow or gold, is your object. Now, if you look at this white one here, it was originally like this and then it has become bigger. You see, so that means the scale factor was what? Greater than 1. Because it starts from 1. This is 1. It's been the same. Then it increases as it is getting bigger than what? 1. You see, so this is when our scale factor is greater than 1. Then if you look at this over here, you realize that you can't even differentiate between that in yellow and then the white one, because they are all the same. The scale factor is 1, you see. But over here, we have our scale factor being between 0 and then 1. It is between 0 and 1. So this is our object, and this here is your image after the enlargement. And as you can see, it has become smaller than the object itself, you see. So anytime you undergo enlargement and then your resultant, which is the image, is becoming smaller, then it means your scale factor you are using is what? Between 0 and then 1. Then this final one is when you have your scale factor being a negative. So negative, you can have a negative that satisfies any of these 3 over here, you see. So for instance, this is when it is 1. Now it starts reducing, meaning your scale factor is becoming smaller, 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 you see. Then it becomes 0. You have something like that. Then it starts going to negatives. So this negative here is it being between 0 and then -1, you see. Now as it becomes bigger and bigger and bigger, if it exceeds -1, then you are going to get an object which is even far bigger than what? Far bigger than the original whatever, you see. So this here, you see, it's now bigger than it. So the negative also satisfies all of this, but the only thing is it is always going to flip to the opposite side. We've done enough of the talking. Let's look at how we enlarge. So we have our first question here, which says we have to enlarge triangle ABC, which has coordinates. So A has coordinates 2, 1, B has coordinates 4, 1, and then C has coordinates 3, 3, by a scale factor of 2 from the origin. So we would work the formula. We will work using a formula, after which we now go to the graph so that you learn how to draw after your enlargement. So our solution, we should know that our scale factor is what? 2, you see. So if your scale factor is equal to 2, then by now you should know how to multiply vectors by scalars, you see. So anytime you have a vector, let's say v, and then you are enlarging it, all we do is we multiply the vector by our scale factor k, you see. And as you know, if a vector has coordinates, let me say x, y, right, then your kv, which is multiplying the vector by your k, is going to be what? The vector times the x component and then the y component. So they are going to get what? Kx and then ky. This is all we are going to apply, you see. So this is how we multiply vectors by scalars. So let's look at how we apply that to our question over here. So as we have said, our scale factor is 2. Starting with vector A. Vector A has coordinates 2, 1, you see. So applying our scale factor to it, then our 2A, which is going to give us what? Our A prime is going to be what? 2 times the vector A, which is 2, 1. You see? And then 2 times 2, and then we have 2 times 1. And all that gives us what? 4, 2. You see? So this is it for the A. Now let's look at the remaining. So for B, the coordinate of B was what? 8. No, it was 4, 1. So 4, 1. Hence, if we apply our enlargement or our scale factor to it, that is K B, which is 2 times the B, which is going to give us our B prime, is then going to be what? 2 times 4, 1, which is 2 times 4 and then 2 times 1. And you know 2 times 4 gives us an 8 and 2 times 1 gives us a 2. So that this now becomes our what? B1. Then for the very final one, we have our C being what? The coordinate of C was 3, 3. So you take it through the same process, and this is what you are going to get over here, following the same process. So this implies that the triangle we have enlarged, A1 give us the coordinate 4, 2, B1 also give us the coordinate 8, 2. And then that of C also give us the coordinate 6, 6. So let's look at how we can plot this. So this here is our graph sheet, and the first thing we need to do is to plot out triangle ABC. So let's look at our coordinates. And from the question, these were the coordinates A, B, and then C. You see, so you are going to plot that out first. Now, since I have already explained in previous videos how to locate points, this shouldn't be a problem. So I've just plotted it out straightforward, you see. Then now we come here and look at these coordinates. The next thing we need to do is what? Plot out these coordinates, you see. So I'm going to do that as well. Then I will explain to you what we have to do after plotting out these coordinates. So this is what we have here, you see. And I do believe I would want to believe, or I would advise that you're also doing it and then you've gotten the same thing, you see. Because mathematics is a hands-on activity. The more you engage, the more you get the concept. So this is what I have here. Now, after drawing this, well, you've been able to enlarge your figure, you see. But what we do is you draw a line, you see. You draw a line from the center to show that this here is the center of what we are doing. That is the origin, is the center of our enlargement. So to show that it is the center of our enlargement, what we are going to do is we are going to draw a line through the center to touch corresponding points. You see, what do I mean by corresponding points? So you take your ruler, and for your first point, you draw a line from your origin to pass through A. It should pass through A and then touch A1. You see, so for mine over here, I'm going to draw my first line. This is my first line, passing through A and then A1. Then I'll draw another line to pass through what? C, and then go and then touch C1. So this is my second line over here. You see that? Then for the final one, I'll do same for what I have over here. To touch through what? B, and then through B1. All right. So this is it over here. You see? And that is all. So this is how we draw what? Enlargement. Now let's take some more examples where we enlarge with a scale factor less than 1. And I would want us to use this same points. the same coordinate. So let's do that. So the question says we have to enlarge this same triangle by the scale factor of half and then -2. So I'm doing this to illustrate how the enlargement becomes a reduction and then when it flips over. So over here, we'll do that of the half, and then at the other side, we'll do that of the -2. I wouldn't be writing much. So for k is equal to 1/2, and then for k is equal to -2. You know the procedure already. So for a prime, that is for k equals 1/2, we are just multiplying each and every term by what? Each and every of the coordinates by half. So we have 2 times half, which gives us 1. Then 1 times half gives us half as well. Then for b prime, so we have 4 times half, that gives us a 2. Then 1 times half gives us a half as well. Then for the last one, we have 3 times half. That gives us a 3/2. And another 3 times half giving us a 3/2. You see, you can work this out to figure them out if there's any confusion. But it is the same principle we use. When you want to enlarge, just multiply by the scale factor and you are good to go. For the second one here, we are multiplying everything by -2. You see, so our A, so in view of that, let me make this A2 and then make this A3. So 2 times -2 gives us a -4, and then 1 times -2 gives us a -2. Then we come to that of B. So for B, we have 4 times -2, that gives us a -8. And then 1 times -2, that gives us a -2 as well. Then for the C also, we have 3 times -2, giving us a -6. And then another -6. So I'll quickly plot this on our graph sheet and then we see how they are. And I do believe you should be able to plot out coordinate on your graph sheet. Okay, so this here is the plot. And if you are to take note of what has happened, this one here in gold. So let me just change this color here. Okay, so the one in gold here was the negative scale factor, you see. And you see, because it has a negative scale factor, you see what has happened? It has shrunk in size. You see that? So after drawing, we then do what? Put our lines to illustrate what point corresponds to what point. You see that? It has actually shrunk in shape. Now we do the same also for this as well. So remember, let me clean that of this and then do for this so you see what it feels like. So drawing our lines, you see the up this here, the C should align with this C over here. So I'm going to draw, or let me do the label so that you see what I'm talking about. So this here was actually your C3, you see, and then and you have the rest following. This is your B3, and then this here is your A3. So let's draw the lines now and then see. So I'm going to draw a line to link what? A straight line. So you are supposed to use your ruler. So I'm drawing a straight line to link my C to my C over here, you see. And then my A, we are using the white one because the white one was the original figure. You remember, this gold here was the scale factor with negative. Then our B also to our B nicely. You see, and as you can see, it has flipped to the opposite side. You get it? So you remember that the previous one, the very first one we did, this was how it was. But then it was on this side of things. And this was actually 2, whilst this was a negative 2, right? So that is it on enlargement. I do hope that you've understood the basics. For these examples, you can always do them yourself to just verify. Okay, so this is just two shapes that they are triangles, they are all triangles. So two plane figures I would like you to try on your own just to test your understanding. So you should enlarge the following from the origin. And the first one, you're enlarging by a scale factor of 2. So that simply means it's going to be bigger. Then the second one is a scale factor of -1. So it's going to be of the same shape, but it will be flipped to the opposite side. You can try this and let me know at the comment section if there is any issue of concern. This is Hard Beyond Numbers, where we learn maths the easy way. Thank you for staying tuned and see you in our next video.